I do apologize for having to do a part 3, but the second video stopped after 10 minutes. So I'm going to work through these last few examples. Again, we need to be able to compare different investments. We want to find out effectively what is our annual interest rate, whether we're compounding once a year, several times a year, or continuously. So these are our equations. I'll pull them out here. You won't have to memorize them. Oh, notice that I did not put the equations or the things he wanted to deposit into. So let me pull those out here. He's going to compare two different plans. Account X, he gets 2.5% compounded quarterly. And account Y, he gets 2.48% compounded monthly. Well, at first he's not sure. Interest rates are close. 2.5 is better if you just look at the rates, but this one, monthly is more often compounded than quarterly. So we're going to use these equations. We're going to say, what's our effective rate of interest for this? And it's 1 plus r over n to the n minus 1. So that's 1 plus r over quarterly is an n equals 4, isn't it? Raised to the 4 minus 1. Over here, it's a slightly different. 1 plus r 0.028. Monthly, n equals 12, right? So that's 12 raised to the 12 minus 1. Now, again, you guys got to be careful when you put these into your calculator. All right. 1 plus 0.025. I'm going to raise it to the 4th, and I'm going to subtract 1. So this gives me an effective annual interest rate. I'm taking it out a few places because I'm not sure how close this other one will be. So it's 2.523 and so on percent. This other one now, which has a slightly lower interest rate, but it's compounded more often. We're going to raise that to the 12, and we're going to subtract 1. This one is, so notice, this account X is better. It gives us 0.0252, where this one is 0.0250. Here's the difference, isn't it? So account X gives us a better effective interest rate. So this is the kind of thing you need to do when you're comparing investments. All right, let's try another example. Harriet has two accounts. So A has this 3.24% nominal interest rate compounding continuously, and B has a 3.25 interest rate compounded semi-annually, which is an N of 2. To maximize the interest the account earns, which account should she choose? So when it's compounded continuously, we had an equation that looks like this. The interest rate will be e to the r minus 1. So e to the r, and then we'll subtract 1. So let's try it. E 0.0324 minus 1 gives me an effective annual interest rate. Taking it out here till I see what this other one gives me. Now, account B, I'll use the equation we used before, where the effective interest rate is 1 plus r over n raised to the n minus 1. Raised to the 2 minus 1. This one is 0.032764. So look at this, 0.329, 0.327. This will give us the better interest rate. Okay? So just to reiterate, you're going to be given all these equations. You just need to be able to use them. You need to recognize, right, if we're compounding once a year, if we're compounding more than once a year, if we're compounding continuously. And then this last section said, if I have two different investment options, which one do I want to use to maximize my interest? So all these equations will be given to you. If I back up, right, these equations will be given to you. You just need to be able to use them, okay? All right, if you have any questions, let me know. We're not doing this homework. I have put a worksheet on PowerSchool for this section. It's a series, actually. It's also 10 problems, but it's not out of the book. It's 10 problems calculating interest using these equations in section 13.4. All right, so let me know if you have any questions. All right, and have a good day. Thanks.